So 10.5 is we're deciding whether two events are independent or dependent. What it means to be independent is like one event does not change or affect the other event occurring. So for instance, the probability of having blonde hair and the probability of wearing a size 7 shoe are independent events because your hair color does not depend on the size of your shoe, and vice versa. They have no relationship whatsoever. They are independent. But dependent events could be the probability of having blonde hair and the probability of having blue eyes. So maybe your hair color and your eye color are dependent events. They depend on one another. Or how much time you spent studying and the grade that you make. That could be dependent. So one affects the other. So the probability of independent events occurring, to find their intersection, you just multiply them together. So you'll be given this formula as well for independent events. A times B. You just multiply them together. That's easy. For dependent events, it's a little bit different because there's not a specific formula for it. You just have to think about the probability of a dependent event. So the best example that I can give when you're deciding if it's independent or dependent, when you're drawing cards, if I said what is the probability of drawing a 10 and then drawing a 7, if I were to replace the card after I drew the first one, if I put it back in the stack, then that would be an independent event. But if I took one card away and then I only have 51 left, then my denominator changes to be 51 because I have one less card. So that means that my card or my stack of cards is changing and then my probability is changing. So we're going to decide, looking at examples, whether they're independent or dependent, and then find the probabilities for those. So here we have number 1. It says for a fundraiser, a class sells 150 raffle tickets for a small gift certificate, 200 raffle tickets for a booklet of movie passes. You buy 5 raffle tickets for each prize. What is the probability that you win both of them? So would this be independent or dependent? Let's say that they're like in separate buckets, these raffles are. They'd be independent. It would be different if they had one bucket of raffle tickets, they drew one name, and then now I'm going to draw a second name. That would be a dependent event. But this is independent because we're going to say there's 2 buckets and they're doing 2 different raffle prizes. So if they're independent, then I'm going to use this formula right here where I just multiply them together. So if I'm buying 5 for each, the first prize would be 5 out of 150. I'm going to multiply it by 5 out of 200. So the probability of winning both prizes, we're going to put these in decimals because you end up getting really tiny numbers. We'll say it is 0.00083. Very, very small chance of winning both prizes. That's why you should never enter raffles. I'm just kidding.
There's no cost, and there's no,
I'm sure there was some sort of cost. It's a fundraiser. There's a cost.
What if it's like a free raffle at a church?
I don't know. It says fundraiser. Number 2, in a BMX meet, each heat consists of 8 competitors who are randomly assigned lanes 1 to 8. What is the probability that a racer will draw lane A in the 3 heats which the racer participates? So this one, what it's saying is, okay, I have 3 different heats and I'm drawing a number between 1 and 8 3 different times. Would this be independent or dependent? Independent, because I'm getting a fresh start every single time. If it were to say you can't have the same lane twice in a row, then that would make it dependent, but it doesn't say anything about that. So what's the probability of getting lane 8? 1 out of 8. And I'm doing that 3 times. So 1/8 times 1/8 times 1/8. The chance of that is 0.002, a 0.2% chance. Seems like it would be higher than that. Okay, number 3, it says while you're riding to school, your MP3 player, we still had these, I guess maybe your iPhone, Spotify, player randomly selects 4 different songs from a playlist with 16 songs on it. What is the probability that you will hear your favorite song from the playlist during the week, so for 5 days? So the first thing that we want to do is find the probability for one day, and then we're going to multiply it by 5 because the 5 days are independent of one another. However, if I'm thinking about, like, okay, so Monday, I'm listening to 4 songs on shuffle. Would those songs be independent or dependent of each other if you have them on a playlist? Dependent, because once you've heard one song, it's done, and you listen to all the other 15 songs before you will start over. So what's the probability? Let's say that I want to hear this one song really badly, and I've got 16 options. What's the probability of hearing the song the first time? 1 out of 16. Then let's say it didn't come up. So what's the probability? I've heard one song, but I want to hear the next one. 1 out of 15. I've got 15 left. Then I have, how many? 14 left. And then my last song, it's 1 out of 13. So this is the probability of hearing your song, if I'm choosing 4, hearing one of the songs from the playlist that you want to hear. And so, yeah, this is just for one day. So this is considered to be one day. So let's figure out what that decimal is really quickly. And then we're going to multiply it by 5 because we have 5 days to listen to it.
But would like shuffle restart, or would it keep on going? Will it start going one?
So let's say like each morning you're going to restart. So what's the probability that one day that you hear that song? Point what? Emily's getting it. You can do it. I don't have it up here, so that's why. 6%. No rush or anything.
You did it wrong.
Wait, which one? That makes sense because each day.
Point what? 0, 0, 0, 2, 3. Okay, so this is day 1. Then I have 5 days, so I have 5 chances. So my probability is going to go up because another 0. Okay, there's a little 0. Then I have 5 days, so I have 5 options. So my probability is going to go up. So I'm going to take this and I'm going to multiply it by the 5 days. So times 5 because I have 5 days. So take that number and multiply it by 5 and you end up getting what? Good. 0.000114. That is a tiny probability. Okay, so dependent events, we saw a little bit of dependent on number 3. But that's basically, when you think about dependent, it's like whenever you don't replace something without replacement. So my probability is changing every time. So when I hit shuffle on my playlist, I'm getting one less song each time out of the batch of songs to choose from. So this formula right here is you will also be given, but I don't necessarily look at the formula because I more just kind of think about what it looks like whenever you don't have a replacement. So it's the probability of A and B is the probability of A times. You would say that this right here is the probability of B given A. So in terms of the last example, what that means is, like in number 3, it's the probability of hearing your favorite song given I've already listened to a song. So we look at number 4, it says you have a bag with 6 marbles, 6 black marbles, 3 red marbles, and 10 white marbles. What is the probability that you will draw 3 black marbles in a row if you put them back after you draw? So whenever you see that, that means that they are what? Independent or dependent? Independent. So I'm just going to multiply them together, and I'm going to assume that I put one in the bag every time I put it back. So the probability does not change. So for part A, what is the probability of drawing 1 black marble? 6 out of 19, and I'm doing that 3 times. So 6 out of 19, 6 out of 19, 6 out of 19. So drawing 3 in a row. And you end up getting 0.0315. Then part B, it says that you draw 3 black marbles in a row if you don't put them back after you draw. So this is without replacement. So that means that they are what kind of events? Dependent. So if I take my first black marble, what's the probability of drawing that first one? 6 out of 19. Then I have drawn one black marble, so my numerator changes to what? 5, and my denominator changes to 18. Then I've drawn another black marble, so my numerator changes to 4, and then 17. Good. When you put that in, you get 0.0206. So my probability definitely lessens whenever you don't replace it, because you have less options to choose from. Okay, number 5, it says you randomly select 2 cards from a standard deck of 52. What is the probability that the first card is not a heart and the second card is a heart? So out to the side, I kind of just want to draw, or I want to figure out what my probability is for each. So the probability of not a heart, or we could call that heart complement, I guess, would be what out of what? How many of them are not a heart?
39.
39 out of 52. Or you could do 52 minus 13, 39. And the probability of a heart is what? 13 out of 52. So part A, it says you replace the first card before selecting the second card. But something that's different is that now my numerator may not change because these 2 events are what? What did we learn on the first page? Like, do they ever intersect? No. So we call them mutually exclusive. So not a heart and a heart, they are mutually exclusive. If you drew a Venn diagram, they would never ever intersect. So for part A, is it independent or dependent? Independent, because I'm replacing that card. So for part A, I'm just multiplying the 2 probabilities together. So 39 out of 52 times 13 out of 52. And that gives me 0.1875. But then I look at part B, and it says you do not replace the first card. So then that would be dependent. And so the first one, so drawing not a heart, is 39 out of 52. But then what changes whenever I don't replace it? So I have drawn not a heart. How many hearts do I have left?
12.
I still have 13 because I didn't draw a heart, I drew a non-heart. So I still have 13 hearts left, but I only have how many cards left? 51. Good. And so then I end up with 0.1912.